Hi everyone, myself Dr. M. Lakshmi Prasad, working as a professor in the Department of Computer Science and Engineering in Institute of Aeronautical Engineering, Hyderabad. In this video, I am going to discuss about the various types of graph. So, graph is nothing but a data structure which consists of set of nodes called vertices and set of edges that relate the nodes to each other. And the set of edges is going to describe the relationships among the vertices, and a graph is going to be defined as follows, like G is equal to V of V. So where V of G is nothing but a finite and non-empty set of vertices, and A of G is nothing but a set of edges or a pair of vertices. A data structure normally have different types of nodes, what we call it as vertices, V1, V2, V3 and V4, and set of edges. So this one what we call it as edges, and this one what we call it as vertices that relate the nodes to each other. The set of edges is going to show the relationship between the vertices, and finally the graph can be able to define as V comma E, where V should be a set of vertices and E should be a set of edges. There is nothing but a pair of vertices. So example of graph, so we are going to have 0, 1, 2, 3, 4 is the set of vertices, and E should be nothing but a pair of vertices, what we called as edges here, E1, E2, E3, E4, E5 and E6. So in this one, so 1 should be the vertices, 2, 3 and then 0, where 0 comma 1 E1, 1 comma 2 E2, 0 comma 3 E3, 3 comma 0 means E4, and 2 2 we should be called as self edge or self loop, E5, and 4 3 is E6. So the vertices is nothing but a pair of values, pair of nodes, and edges is nothing but the pair of vertices should be treated as edges here. So when x comma y is an edge, we see that x is adjacent to y and y is adjacent from x, and here 0 is adjacent to 1, 1 is not adjacent to, that means so it's, 0 is adjacent, right, and 1 is not adjacent to 0 since there is no edge from 1 to 0, and 2 is adjacent from 1. So there are different types of graphs, what I call like directed and an undirected graph. So undirected graph has no orientation, what we call it as no arrowhead, and directed edge has an orientation called arrowhead. And in undirected graph, all edges are to be undirected. Undirected graph, all edges are going to be directed here. So if an edge is going to make a direction, then it should be treated as directed edge. And edge does not have any kind of arrow, so then it should be treated as undirected edge. Similarly, the graph, what we call it as directed graph, and the graph which is going to have undirected edge, what we call it as undirected graph. So undirected and directed graph has no orientation. So that means which is going to have no arrowhead, and directed edge is going to have an arrow. And for this undirected graph, all edges are going to be directed one, whereas directed graph, all edges are going to be directed here. Suppose if I'm going to consider a weighted graph here, so the edge which is going to carry the values, what we call it as weighted graph here. So normally if I want to represent it, so these are the set of vertices. and this should be the set of edges. So in this edge, if I'm going to assign a values like this, then it should be called as weighted graph. So the graph in which the edges are going to carry the value, so that should be treated as weighted graph. So in this one, suppose the price cost from going from Atlanta to Washington. So I want to show it. So the price should be able to vary 600 rupees. Let it be treat $600. And similarly, I want to move from Denver to Chicago. So the value is 1000 like this. So the directed graph is an incident to vertex J and incident from vertex I, and vertex I is incident to vertex J and vertex J is adjacent from vertex I. So this should be the conventions in directed and indirected graph. So when it comes to this graph terminology, so we are going to see about adjacent nodes. So the two nodes are said to be adjacent. So if they are connected by an edge here, suppose here is the vertex and here is the vertex. So I'm going to give an arrow like this, right? So what we called as the 5 is adjacent to 7. Okay. So but 7 is adjacent from to be convened. So next one is a path. So path is nothing but a sequence of vertices that connect the nodes in the graph. And simple path is the path in which all the vertices, except possibly in first and last, should be the different one. And the complete graph is the graph in which every vertex is directly connected to the every other vertex here. So the path is nothing but a sequence of vertices that connect the two nodes in the graph here. And simple path means so in which all the vertices except possibly in the first and last should be the different one. And the complete graph is the graph in which every vertex is directly connected to every other vertex here. So the path, so if I'm going to consider graph here, so what is the path from to reach from V1 to V4? So directly I can able to go, otherwise I can able to go this way, or I can able to come this way. So there are different paths, so V1 to V4 or V1 to V2, V2 to V3 and V3 to V4 or V1 to V2, V2 to V4. So these are the different kinds of paths that are available here to reach from one vertex to the other vertex. A simple path means a simple path is the path in which includes all the vertices except possibly the last and first should be the different one. So the first one, last one should be the different, that should be treated as simple path. And a complete graph means that in every vertex is directly connected to every other vertex. Suppose if I'm going to take like this, so this is not a complete graph. So for every vertex, there should be corresponding edge to the other vertex. If I'm going to consider this one, and this one. I'm going to consider this one, and this one. So this one should be treated as complete graph. And next one, what is a cycle here? So cycle is nothing but a simple path with same start and end vertex. So the degree of vertex is nothing but the number of edges incident on vertex side. So simple cycle is nothing but a path. So in which the vertex should be same for starting and ending one. So and then the degree of vertex I is nothing but the number of edges incident on vertex side. So suppose 1 to 2, 2 to 5, 5 to 7, 7 to 6, 6 to 4 and 6 to 1. This should be called as a cycle. So why? Because the starting and ending is same here. And how are we going to calculate the degree here? So the degree of the vertex. So the degree of vertex can be written as number of edges that are incident to this edge, what we called as degree here. So degree of 8 equal to 2. So what is the degree of 10? That should be 1. So only one edge is incident on this. So when it comes to the undirected graph, it should be something different one. So undirected graphs are to be connected. So if there is a path between the two vertices, and these graphs are strongly connected if there is a path from one vertex to another one, and these directed graphs are weakly connected if there is a path between the two vertices ignoring the direction here, and complete graph has an edge between every pair of vertices. So in undirected graphs, so they are to be connected. So if there is a path between one vertex to another vertex, and directed graphs are strongly connected if there is a path from one vertex to another one, and directed graphs are weakly connected if there is a path between the two vertices. And we will see about the terminology like loops. So what should be the loop here? So the loop is nothing but an edge that connects to the vertex itself. So in the graph, if a vertex is there, so the edge which is going to reflect this same to itself, it will be what we call it as a loop here. And path, what should be the path? So path is nothing but a sequence of vertices, so such that each adjacent pair of vertices are connected by an edge. And simple path is the path in which all the vertices, except possibly the first and last, should be the different one. And multiple edges means the two nodes may be connected that should be greater than one edge. And simple graph has no loops and no multiple edges. So here, simple path is the path in which all the vertices, so except possibly in first and last, should be the different one, and the two nodes have to be connected that should be greater than one edge. And simple graph has no loops and no multiple edges also. The next one, graph properties. So the number of edges that should be in undirected graph. So what should be the equation for that? So the number of possible pairs on a vertex graph is given by n into n minus 1. A simple edge UV should be same as VU, and the number of edges in undirected graph should be written as n into n minus 1 by 2. So when I'm going to construct this undirected graph, so the possible number of pairs of n vertex is that n into n minus 1. Suppose if n value is 3, suppose I'm going to consider a graph like this. So the possible number of so that should be 3 into 2, that should be 6. So the possible number of pairs that should be in the given vertex is that, so v1 v2 v2 v1, similarly v1 v3 v3 v1, and v2 v3 and v3 v2, so totally 6. Similarly, the edge should be same as the same edge as VU. So the number of edges in the undirected graph should be given by n into n minus 1. So for this one, so the number of edges will be 3 into 2 by 2. So the number of edges will be 3 here. So 1, 2, and 3. So like this, we are going to calculate the number of edges in undirected graph also. So how are we going to calculate the number of edges in directed graph? So the possible number of pairs in one vertex graph is given by this one n into n minus 1, and each edge is not same as the VU. So the direct number of edges in directed graph is given by n into n minus 1 only. So in case of undirected graph, it should be n by 2, whereas in directed graph, it should be n into n minus 1 only. And the number of possible edges in the directed graph should be less than n into n minus 1. So in this one, 1, 2, 3, 4, 5, 6. So number of edges will be 6 into 6 minus 1, 30 here. So the 30 possible edges I can able to draw here. So 1, 2, 3, 4, 5, 6, 7, 8. So what is this in degree and out degree? So in this one, in degree and out degree means, so the number of in degree, so the number of vertex uh, incident to the vertex, the number of edges that should be incident to vertex should be considered as in degree. The number of edges that is leaving from the vertex should be called as out degree. So the number of edges that is leaving from the vertex will be treated as out degree. So if I'm going to consider 5, so what should be the in degree of this? So in degree is only one incident, and out degree that should be 1. So the in degree should be defined as the number of edges that should be incident to I. So the number of incoming edges. The number of edges that incident from I that should be our number of outgoing edges should be treated as out degree here. So when it comes to the types of graphs, so just now I discussed, so undirected graph. So all the edges are to be undirected one, and if there is a connection, then it should be treated as a symmetric. When we say the graph is undirected, directed means all the edges are directed if an edge implies only one direction of the connection. And weighted graph is the graph where each edge is associated with a numerical value called weight here. So undirected graph, so all the edges are to be undirected one. Undirected graph means all the edges are directed, and if an edge implies that one direction connection here. And weighted graph means weighted graph is the graph where each edge has an associated numerical value called weight. So what is this undirected graph? So undirected graph means a pair of vertices representing any edge in unordered. That means the pairs UV and VU represent the same edge. So let us consider a graph G2. So the vertex of the graph should be 0, 1, 2, 3, 4, 5, 6. And edges of the graph will be 0, 1, 0, 2, 1, 3, 1, 4, 2, 5 and 2, 6. So G2 is also a tree, so it should be a special case of the graph. So every tree becomes a graph, but a graph does not become a tree. Yeah, undirected graph is said to be connected if there is a path between every pair of vertices in the graph. When it comes to directed graphs, so digraph, each edge is represented by ordered pairs UV. So let us consider the graph. The V of G should be 0, 1 and 2, and the edges should be 0, 1, 1, 0 and 1, 2. So the directed path in the directed graph is a sequence of distinct vertices such that there is an edge from the vertex to the sequence to the next. So weighted graph. So weighted graph is the graph where each edge has an associated numerical value called as a weight, and these weights may be in the case of undirected graph, and the weight of an edge is offered to as a cost of the edge here. Suppose in the graph, suppose the edge is going to hold some values like 5, 3, 4. So this and all will be considered the cost of edge normally. So in weighted graphs, the graph is in which every edge is going to associate with numerical value called weight, and this weights graph may be in case of directed and directed also. and the values what is associated with each edge should be considered as the cost of an edge. So graph traversal algorithms. So in graph traversal algorithms, there are two types of algorithms like BFS and DFS. So in breadth first search, and DFS means depth first search, and BFS means breadth first search. So normally traversing means that it should be visiting all the nodes of the graph exactly once in well-defined order. So for that, we have two types of algorithms like BFS and DFS. So DFS is nothing but so visit the node and then put the children in a stack and queue, and for each cell in the list here. So if I'm going to use a stack so recursively, then you can able to get DFS. Suppose if I'm going to use queue, then it should be BFS. So what is this basic idea of breadth first search is that so we have to visit all the children before first grand chain. So the visiting order means so first we have to visit the vertex, so then visit the neighbors, and then visit all the neighbors of its neighbors. So BFS is best in finding the shortest path, and but in this main disadvantage is that so it needs more flags to preventing the infinite loops. So BFS is implemented by queue. So initially I have to create a queue, and then I'm going to be mark the visiting vertex as V, and then I have to put in the circular queue. So while queue is not empty, so we have to remove the head of the queue, and then mark and end queue all the unvisited neighbors of the queue as well. So graph representation. So for a graph, we have two types of representations like adjacency matrix representation and adjacency list representation. So these are the two widely used graph representation techniques. So what is this adjacency matrix here? So adjacency matrix is nothing but a square grid of Boolean values. So if a graph contains n vertices, then the grid contains n rows and n columns. So if the two rows are to be numbered I and j, so the element at I and j should be true if there is an edge from I to j. So normally this adjacency matrix should be a bit of Boolean values. So whenever there is an edge from one a vertex to another vertex, then I have to mark it as true. Otherwise, I can able to mark it as false. So V1, V2, V3, V4. So I'm going to consider all the vertices along row wise and column wise. And if there is an edge from V1 to V3, I'm able to mark as true. And if there is an edge from V1 to V2, true. Then remaining all should be false. Like this, I have to concatenate. So adjacency matrix should be represented like this. So this is the given graph. In this given graph, so 0 to 0 false. So I have an edge from 1 to 3 only. So I have to make it as true here. And I have an edge from 1 2 to 4. So 2 to 4 true. And from 3 to there is no edge. So no, I have to mark it as true. And for 4 it should be 4 to 3. I have to mark it as true. And from 1, so 1 to 3. And 0 to 2. So instead of representing zeros or 1, I can able to convention it either ones and zeros as well. So if I'm going to consider 1 2 3 4 5 x-axis and 1 2 3 4 5 along y-axis. So if I'm going to make a convention like this, so if there is an edge from 1 to 2, so I have to mark it as 1, and 1 to 3, 1 to 4. So remaining all zeros. So if I'm going to consider 2, so I have an edge from 2 to 1. 2 to 4. If I'm going to consider 3, so 1, 4, and 5. 1, 4, and 5. If I'm going to consider 4, so 2, 1, 5, 2, 1, 3, 5. and for 5 I have only 3 and 4. So like this I'm going to represent the adjacency matrix here. So this is the way of representing in case of directed multiple graphs. So the next one is that adjacency list representation. So in this one, so normally I'm going to use the n-dimensional array of linked list. So in linked list we are going to have an header, and that header is going to be connected to the next node, and from that one to n2, and from that one to n3. So like this we are going to represent the linked list representation of adjacency matrix as well. Suppose if I am going to construct a graph like this, so adjacent of 1 is 2 and then 3, and adjacent to it should be 3 only, and adjacent of 3 there is nothing. So since there is no leading edges going on, and adjacent of 4 is 3. So how much storage is required in case of adjacency list? So the degree of the vertex V should be defined as incident edges, and the directed graph has in degree and out degree. So normally the degree of vertex in directed graph should be written as in degree plus out degree value. So in degree out degree means so what should be this out degrees? That should be given as mod of edges. In case of undirected graph, so it should be 2 into multiplied by mod of E. So if I'm going to represent, so I can able to go from V1 to V2 and then V2 to V1 also. The two possibilities appearing. So that's why I have multiplied with 2 and not 3. So implementing graphs. So this is the way of representing a graph using adjacency representation. So taking along the vertices along the x-axis and y-axis, and if there is an edge, we have to mark it as 1, otherwise it should be 0. Representation of linked list representation of graphs here. So for that what I am going to do, so initially I have to take the vertices, and that should be connected to what should be the next node vertex, and that should be A to B. The cost is 8, so this is the node, and this is the value, weight value, and from B to D it should be 6. So not B to D, A to D, so it should be 6. So similarly, if I'm going to construct B, so B to A and then B to C. So like this I'm going to construct this adjacency list as well. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.